Awesome. Okay, so today we have a pretty exciting session. We're going to be talking about AI sort of in the real world, looking at some real world use cases, what people are actually building with AI today, and also take a look into the future at what's coming. Um, so yeah, I'm Victoria. I work at Weaviate as a machine learning engineer, but my role is like half content, half demo building. So I get sort of the best of both worlds of interacting with the amazing AI community, but then also building really cool stuff. So I love my job and also love Weaviates. So I thought I'd start by recapping a little bit what we went over in webinar 1 and webinar 2, just in case you hadn't joined, and to just kind of give a memory refresher, so we're all on the same page. Reminder, you can find all my slides on slides.victoriaslocum.com if you're looking for those. And also after this, all the webinar recordings will be sent out along with more resources. If you haven't been at the first two webinars, lots of resources in there as well for you to continue your journey with. So in the first webinar, we talked about vector embeddings, and this is sort of the foundational concept. Most things in AI start with vector embeddings. And vector embeddings are how we encode our data to encode its meaning within a numerical representation, so that way we can use it for downstream applications, whether that's LLMs using vector embeddings, or vector search using vector embeddings, or RAG systems, or chatbots, or fancy multimodal e-commerce search, which we'll talk about in a bit too. So it's kind of the foundation layer. And so we went over that RGB color codes are sort of a good way to look at what a vector embedding is. So an RGB color code has 3 numbers in it, ranging from 0 to 255, and that indicates how much red, green, or blue is in a color. So 000 would be black, and 255, 255, 255 would be white. And the nice thing about having 3-dimensional vector encoding the color is that we can graph it really nicely on a 3-dimensional space. So you can see that similar colors are being grouped together, and less similar colors are farther apart. And this is exactly what a vector embedding is, right? It's a sequence of numbers. Instead of being 3 numbers, it's a really, really long sequence of numbers that represents what something means. And each number or dimension of the vector is sort of indicating a feature. We don't know what that feature is because that's something the vector embedding model decides to encode. But we can think of it in a way of each of those numbers as encoding a characteristic, and that the vector embedding is then able to represent the meaning of whatever the thing is, whether it's text or an image or audio or video, anything. So we also talked about how you actually choose an embedding model, and we went through that there's 2 main categories of things you can consider. One is data performance. So that's language specificity. Do you need it to be purely English? Do you need multilingual support, code support, etc.? What are you using it for? Are you using it for retrieval, for search? Are you using it for ranking? Are you using it for summarization? That may change the performance of your vector embedding model that you should choose. And then obviously, like, how well does it actually work, and how well does it actually work on your data is always really, really important to find out. On the other side of things, you have infrastructure considerations. So that's inference costs. How much does it take to run your model and generate your embeddings? Or storage costs. Once you generate those embeddings, they can be different lengths, different number of numbers, or different number of dimensions. So higher number of dimensions means it can encode more nuance in the meaning and can give you better accuracy. But it's also going to mean that your costs for storage are going to go up. And then thirdly, you have the speed, so latency throughput of your whatever you're hosting your model. So how often do you need to access the model? How often do you need to generate embeddings? Stuff like that. And the main point I hope you took from the first webinar, and also a little bit of the second, is that machine learning is really full of trade-offs, right? Just looking at how accurate a model is or how well it performs on a specific data set is not a good indicator of how well it's actually going to work in the real world, right? Or I don't know. There's so many different little things that you can choose because every use case is different and requires different things. If you need a higher amount of accuracy, you're going to trade off a little bit of speed or cost, right? Or stuff like that. So there's so many different trade-offs in machine learning, and that's why I also think it's really important to learn about this so you understand for your use case what is most important. So moving on, in webinar 2, we talked about vector search. So we took everything we learned about vector embeddings and we applied it to a search scenario. And we started off with saying that search systems run the world. Most of what we do on the internet, the way we interact with it, is through a search, right? Whether it's a Google search or you're searching on Amazon or you're trying to find this slide deck that your colleague made, you're trying to search through all the information we have out there, because we have a lot of information in the internet, and find the right information out of that. And I started off with the saying that a good search system is nice, it works well, you're happy. Bad search system is really, really annoying. And it can be really frustrating to deal with. And then we talked a little bit about the difference between keyword search and vector search. So in pure keyword search, you're looking for exact matches between a query and a document, right? So if you search in keyword search for Coca-Cola, you're going to get all the Coca-Cola products. Vector search is a little bit different. With vector search, because the vectors encode the meaning of a thing, you can then search based on meaning, not exact keyword matches. So when you search for Coca-Cola, maybe you'll get Pepsi and Fanta and all these other related drinks because it's understanding what you mean behind the query. And we also went through an example of how you can implement vector search from scratch in Python in just under 20 lines of code. And we looked at how vector search really is just math at its core concept, right? You're calculating distance between two vector embeddings to calculate similarity to return related results. And that's just a math calculation. The weird machine learning part is really in the vector embeddings as a basic concept. So why did you even need a vector database? Well, we looked at that too. We looked at calculating distance between a query and a document for every document is called KNN, or K nearest neighbors. And for every new document, you have a new calculation, which means that scales linearly. So this means it's not really suited for really big applications. Versus ANN algorithms, which is what vector databases use. These are approximate nearest neighbor algorithms, and they use some sort of concept or index or data structure to basically allow you to search through all your items without needing to calculate the exact distance for every document and query pair. And this means it scales logarithmically. So you can have super fast search speeds. So you can search through 1 million or 1 billion vectors in just a few milliseconds. With that, we talked about what at scale really means. So when we talk about the difference between 50K vectors and 1 million vectors and 1 billion vectors, it gets a lot different, right? When you're talking the difference between 1 million and 1 billion, when you're talking to at scale, there's a huge amount of stuff that has to go into dealing with a billion scale search. And the thing about the current landscape of AI is that we're moving more towards vectorizing more than less, right? I talked about a little bit that there's so much data on the internet. And if we need good search systems, we also need a way to vectorize all that data and store all that data and search through all that data. And that is billions, billions, billions scale, right? And so we need a way to efficiently store and search through billion scale, which is a lot different than when we're looking at million scale or even 50K scale. Yeah, okay, so I'll pause quickly. If anyone has any questions, they can drop them in the chat quickly. Otherwise, we can move into the main part of this webinar, which is AI applications in the real world. Okay, not saying anything. Then, I'm going to talk about 4 main use cases today. The first one is going to be search at scale. So what does it actually mean to search through the billion scale? What do you need to know about? What do you need to think about? Second one, we're going to talk about Retrieval-Augmented Generation. This is going to be the most exciting part because I'm going to demo an application that we have not yet released. You all will be the first to see it, whoever's here. And thirdly, we're going to talk about e-commerce with artificial intelligence sort of concepts, vector database concepts, what you can do to kind of level up e-commerce applications with AI. And fourthly, we'll go into sort of the next horizon, or what we're seeing as the next horizon, and that is agentic architectures and workflows. Awesome. So search at scale, I think there's four main things that I want to cover here in detail. That's flexible deployment and architecture, hybrid search that scales, having customizability without sacrificing usability, and then community enablement and education. So let's start with flexible deployment and architecture. I mentioned a little bit earlier that when we think about all the things that you can do with vector databases, the amount of use cases and the differences in those use cases are really big, right? So when you're thinking about running an e-commerce store, you mainly have all your product data in one collection. And when you're looking at your priorities for that, you're looking at fast search speeds, but maybe top level accuracy is not super high in your priority list. That's a lot different than when you might be looking at a user-based system. So let's say you're creating an app where you allow users to write their diaries, right? So for every user, you need a collection with all their diary info that they upload in, and you don't really want any other user to access that information. So you could have this in a single collection and just have a user property that then you filter on. But the problem with that is it becomes really, really easy for one user to access another user's data because of a error behind the scenes, a developer error, or just something going wrong with the database. So the user data in there is not very secure. And that's why we have built our multi-tenant system. Well, part of the reason why. So multi-tenant systems are where tenants or like little collections of data are completely isolated from each other and have like granular controls. So instead of a single tenant system where you have all your data in one bucket, like for an e-commerce use case, multi-tenant systems allow you to completely isolate your buckets of data. And then you can also do things like flexible storage with those. So in this little animation here, it shows our different storage types that we have for a multi-tenant system. This Academy course also goes through it in detail. And this is a native feature within Weaviate that basically allows you to take a tenant and move it into hot storage. So it's super fast and readily available using a HNSW index. Warm storage, so it's in sort of disk. It's not as it's not as fast, but it is still available. Or cold storage, where it's moved off to cloud storage. So that way it's sort of frozen and it's taking up a lot less cost. So you're kind of moving from highest cost to lowest cost, and then highest speeds to the coldest tenant needs to be warmed up before it can be used. And this can lead to really cool use cases, like in the diary example I was mentioning earlier. Let's say when a user logs in, you take their little tenant from cold storage, where it's not using up any of your cost, and then you move it into hot storage so that when they're actually using it, you have it available and super speedy and fast. And then when they log out or when the application isn't active, you move it back to cold storage where it's not costing you anything, which is super interesting. And this little course is not that long to go through. It doesn't take that much to set up. And that's because it is a feature really built into the core of Weaviate. It's something we put a lot of development priority on because we saw it being used by customers like Instabase within customers like Instabase to be able to do things like process 500K documents per day and scale as a customer-based system. So super interesting stuff there. Let's move on. The next thing is one of my favorite topics ever. This is the first thing I started deep dive learning about when I came to Weaviate, and that's hybrid search. So in the first webinar, or I guess second webinar, we talked about vector search, and hybrid search is taking that a step further. So instead of just doing pure vector search, you can add keyword search into that system, so you can still get the availability of exact matches without losing that meaning, searching based on meaning that vector search or semantic search gives you. And this is exactly what Stack Overflow did. So they wrote this blog post back in 2023. Basically, they had a lexical search system, and it was working all right, but they were struggling with meaning-based searches. So they have this great quote here: to get good results, you shouldn't need to know any magic words. With semantic search, you don't need to know any magic words. So when you're searching with keyword search, you need to know the exact right search terms to be able to return the related results. But semantic search is able to understand the meaning behind you. However, what they noticed that hybrid search gave them better performance, because sometimes you still do want those exact matches within your results. For example, if I'm searching for a bug on Python, I don't know, 3.14, I want it to return results, prioritize results that have Python 3.14 in them. And semantic search is not as good unless you have a very specifically trained model at calculating those exact similarities. And so that's where the combination of keyword search and I forget what they said it in here. The combination of keyword search and keyword search and semantic search kind of gives you the best of both worlds. And yeah, if you're interested in learning more, I have a webinar that I did a while ago now with Sebastian that'll give you more information on the how. Yeah, got pretty slides there too. So good stuff. Okay, next up, talking about search that scales, talking about customizability without sacrificing usability. This is one of my top topics when I'm looking for any sort of tool or company I want to work for. This is sort of my deal breaker. And that's a tool that has out-of-the-box defaults. So that means you can get started right away without having to set up a million bajillion different little variables, right? Like you don't have to go through and learn everything. You can just kind of like get something up and running right away because, believe it or not, I'm a very impatient person when it comes down to it. But after you get something up and running right away, and like we talked about before, every use case is slightly different, you still need to be able to customize what you're building to your own use case. And I think that's super important with tooling, is being able to go down for the things you really care about and change those defaults to something that makes more sense for your application. And I think this is something that Weaviate does really, really well. So we saw in the last two webinars with the demos I was doing, it was not that hard to get started with a little prototype application in 10, 15 minutes, right? But we were still able to go down and customize things like add hybrid search, customize the fusion algorithm hybrid search. You can customize the limits. You can return with a different sort of limit procedure. You can customize the HNSW algorithm on Weaviates. So all these things really allow you to have granular control over the things that matter for your application. And one of the things I think I also really appreciate about Weaviate is the first slide was on, I guess, yeah, okay, flexible deployment architecture, talking about the flexible deployment part, but also this part. We offer so many different ways that you can deploy Weaviate yourself. So in the last two webinars, we've been looking at Weaviate Cloud because it's super, super easy to get started. But you can also deploy it with Docker, Kubernetes embedded on your own device. You can deploy it with AWS or Google Cloud or I don't know, basically anything you want, it is possible to use with Weaviate. We really prioritize meeting the customers and the users where they are, not making them change the entirety of their workflow just to be able to include AI in their application, right? We just want people to be able to build easily with AI. And that's something we also do with our model provider integrations. So we have so many different integrations. I use this list a lot because I don't even know what we have all the time, and we're constantly adding new ones. We just added NVIDIA actually at the latest release, like Anthropic, OpenAI, Cohere, AWS, everything you want. And that's all about, allowing people to build AI within their own architectures that they already have. But yeah, top features of tools for me is that. And the fourth one I want to talk about building at scale is that it's not only about having these features and functionality and that you're able to do these things. It's also important that you know how to do these things and you have the trust and the resources to be able to execute on it, right? And this is one of the reasons why Weaviate Core is open source, why we have an open source database. You can go in to the GitHub and look at the code, see our roadmap, see everything we're doing. This scares me for sure, but you can look if you want to. That's why we do our developer events like the Hack Nights all over the US and Europe. Why we bring like all different technologies together at these Hack Nights in order to enable developers to build with these tools and try out these tools and be able to ask the experts of these tools. And my colleagues, Connor and Charles, and all these other ones are also like publishing research papers and doing the Weaviate podcast. And that's why we're so active doing these webinars and on LinkedIn. It's because the stuff isn't important that it exists. It's important that people are actually able to build with it and use it. It's one of the things I love most about my job. Okay, so that was the spiel about building search at scale. Now let's move on to taking it one step further, and that's with Retrieval-Augmented Generation, or RAG. RAG pipelines are super cool. Basically, they take vector search and add another step on top of it with the generative model to be able to return a response. So the first step is ingesting all your documents into your vector database. So that's getting embeddings and then putting in the vector database. Then a user comes in with a query, it's embedded, you retrieve context from that embedding, you put it in a prompt, which is the augment step. You take it out, give that response to an LLM, which then outputs a response back to the user. This is a pretty basic workflow for retrieval augmented generation, but we have a ebook that goes into so much more detail. It goes through the basics, but then it also goes really deep down into all these different strategies, advanced strategies for chunking or query transformation or fine-tuning embedding models or re-ranking. So whether you're just starting out or you have an existing RAG pipeline that you're trying to improve, would definitely recommend looking further here. But what does this actually look like in demo form? So now we're going to come to our first demo, and that's Verba. I'll reload this. Hold on. So Verba is our open source RAG demo, and we've been building it all of last year. Edward is the sort of brain behind Verba, and it's a classic RAG pipeline, completely open source, so you can go in here. This is our hosted version. It has all the Weaviate documentation in it, but you can also go to GitHub, run it yourself, and upload your own documents in here. I used it when I was doing a bunch of research on like machine learning papers, just uploaded them and then had a chatbot. And more resources there. But so what happens is the same as I showed in the beginning. So if we ask a question, search. Basically, what's going to happen behind the scenes is this question is going to be embedded. And then it's going to be used to search through Weaviate for all the related context. And that's going to pop up here. So you can see the different chunks that it's coming up with. Here, chunk 2, this one has high relevancy. And then that context is going to be fed into a prompt for a large language model, which then outputs a response over here. So pretty cool, very useful. The difference between this and pure like ChatGPT is that by adding all this extra context with the large language model, we're able to have source reliability. We know where this information is coming from, first of all, but we can also add a lot more context. So out of the box, ChatGPT is not going to be able to tell me what is hybrid search in Weaviate and even what Weaviate is. But by adding that extra context and being able to retrieve that from the vector database to give to the large language model, we're able to get fine-grained responses specific to our data. And we could even run pipelines like this completely open source on our own infrastructure. I did a video with that with Edward. I don't know if it's still up here, but anyways, like running this whole thing with Ollama locally, hosting it locally, all that stuff. So super fun, but so industry sort of application of this in our Weaviate documentation, we have this cool thing. Wait, let me go to the docs. Actually, I can see it right here. Okay, we have this cool thing called Ask AI. And this is powered by Kappa AI, and Kappa AI is powered by Weaviate. So it's this whole inception thing going on here. And Kappa AI is basically a RAG pipeline, but much more sophisticated. So it's used for technical product questions and documentation chat. So behind the scenes in Kappa AI is storing all the Weaviate documentation, which then allows us to ask it about Weaviate related questions and have it return a response. I actually just used this so much today as I was building a new demo. Let's do Python query. I really hope this works. I didn't test this query out before. I actually don't know if it's still called AutoKit. I don't know. We'll find out. Oh, perfect. Okay. So gives us a little response. It even gives us code because this is a specific trained thing specifically for technical things. And so Kappa AI is super good at returning code, like auto limit is auto cut, and even does additional operators and stuff like that, and gives you the sources too. So this is RAG, right? Simplest form is just adding generation to your search results, and then you can get much more fine-grained. And basically every part of this process, as we saw here, whether it's indexing, the pre-retrieval, retrieval, post-retrieval, stuff like that. Okay, so in Weaviate, I talked a bit before about customizability, which you can learn way more about here, but then I talked about ease of use and getting started right away. So this is a vector search query. We looked into how to use this the last webinar, but it's just like your collection.query.near text, add in your query, add your limit, boom, results. To set up RAG in Weaviate, you just need one more line of code. And you can say a grouped task. So for this one, it'll query your collection for all the sources related to history of Git. And then it'll put all of those sources with this prompt, the large language model, and then you'll get a summary of the key information back. So group task is using all of the chunks returned. Or you can do a single prompt, which is reviews or collection.generate.near text, adding your query, single prompt, translate each and every one of the responses returned into French using emojis. How fun. So this is for every single one, do a different thing. So again, easy, out of the box, get started, build a RAG pipeline in 5 lines of code. Super fun. Okay, this is the part I was talking about where you're seeing a demo never before seen by anyone outside of Weaviate. You are getting to see Elysia. And Elysia was developed by Edward, the guy who made Verba, and Danny. Edward actually just gave a talk recently on why Verba is shit. So, um, and this is because he's been building Elysia, which is mind-blowingly good. So let's take a look at it. This is Elysia. It has this really cool bubble, which I adore. Let's just ask Elysia, what is Elysia? Why do you need me? Oh, that's not good. I hate live demos. Okay, I think I need to create a new conversation. Nice. Please work. Yeah, okay. So Elysia, as it will hopefully tell you is an agentic RAG framework. Um, so it uses a decision tree to decide what response to return, what tools to use. Okay, so let's ask it, what data do you have access to? Okay. Okay, so we have lots of different data sets in here about lots of different things to kind of show that it's actually querying the right data. So we have example GitHub issues from Verba, example email chains that have been artificially generated, and Slack conversations that have artificially been generated. We have a whole e-commerce data set in here, a weather data set, articles about machine learning, and Weaviate documentation. So if we, for example, ask some fashion items I could wear to it will be able to return us fashion items, but there'll be something interesting that comes from here. So the first thing is it's telling us it's retrieving fashion items, and it's going to be uh, writing its own query based on this to be able to search through that collection. So if we click on here, you'll be able to see that it's doing a hybrid search query. The query text is Garden Tea Party, but then it's also adding some more filters um, for cottagecore and fairycore, which are the two of the collection names, and then adding a limit of 5. And we can see here that it's returning some great products for a Garden Tea Party. Yeah. And then what it decides to do at the end is give a little summary. So if we go back into our tree, what the agentic part of this means is instead of just taking this text, putting it in a query and searching through it, there's a large language model at each of these nodes that's deciding what the next step should be. So when I inputted this instruction, the large language model was like, okay, what step do I need to take next? And it decided to do a search. So then it was like, okay, do I need to do a query search or an aggregate search? And it decided that based on that initial instruction, it needs to do a query. So then it built the query, executed the query, and then it was like, okay, what step do I need to take after that? And it decided to summarize the results at the end. And so it's using a large language model to basically make decisions, which we'll go into a little bit at the end. But you'll also notice that this is dynamically displaying data, right? So let me give you a different example just to sort of show this. Again, look at this bubble. It's so cool. Okay. So I'm asking what the most recent issues in Verba are. So the first thing it's going to do is decide what to query or what to do out of those actions. So it decided to search the Verba GitHub issues dataset, perform a query to get the recent issues. So we can see here the query was just fetch objects. So instead of doing a search, it's just sorting by the last updated property and giving a limit. And it's actually displaying the data differently here. So based on what the data is, it can decide to display the different data in a different format, returns the results, and gives a summary. Then I can ask, is anyone talking about these issues on Slack? And what this is going to do is have the conversation history to basically decide how to write the query to search through the Slack messages to try to find out if any of those are present in Slack. And again, displaying data in a slightly different format. So instead of like an issue format here, as just messages, we can see the query it decided to go with is a hybrid query. And it decided on this text, right? And every time I've done this, the query text has been slightly different. This is wrong. So sometimes it's not completely right. But if we go into the tree again, you can kind of see this is because we really wanted it to like have insight into what it's actually thinking, what it's actually doing. So it's searching and then giving a text response for the most recent issues and searching and giving a text response. Oh, I really want to go, okay. The reason it knows how to do this all is because for every collection, we've actually given it more information on what the collection means, but also all the different fields in the collection. So it can have this information to decide which actions to take next. Yeah, so super cool stuff. This is not released yet, but it will be soon. Very exciting stuff. And definitely follow Edward and Danny to stay updated on the release of this. I'm so excited. Okay, so let's talk about e-commerce with AI. So e-commerce is at the intersection of a lot of different vector search strengths, but also difficulties. And this is multiple reasons. I mean, e-commerce, I think, has always been sort of an interesting field because of the sort of nuances that you can get into with it. So it's usually a large scale single tenant search system. I mean, you can have different setups where you can maybe have some multi-tenancy for user-based things, but at the core, it's a large scale single tenant with all your products in the collection. You can do things like multimodal embedding, so you can embed product images. Like Moonsift was experimenting with this when they were building their AI-powered co-pilots, where you can see here that because of these fine-tuned vector embeddings, you get much better results for a skirt with a pattern inspired by ocean waves than just like a pure Google text keyword search. So super interesting. And yeah, with the recommendation and personalization systems, we have a lot of, I mean, vector search is great for recommendation and personalization systems because of its dynamic ability and being able to, again, encompass meaning and maybe generalize better than just having pure matchy stuff. So out of the box, like vector search can be a great recommendation engine, trying to find similar items just by the embeddings of the items, not from a bunch of logic. And also cool things with like query transformation. When you're searching through e-commerce, a lot of times people will spell stuff wrong. People might not input the best queries into your e-commerce application, but you don't want to have that to be a limiting factor, right? You want them to be able to still get good results, even if they misspell something or don't have the exact right words in the query, which is something vector search can be really powerful at. So super interesting things there. I really want to get to agentic architectures. We're close, so I'm going to skip past this a little bit, unfortunately. So we can talk about agents, which is sort of the next horizon that I'm seeing on the line. We will have another blog post tomorrow, but we've been doing a lot of sort of talking about what do we actually mean about agents when we're talking about agents. This blog post by Anna, published last week, is a great introduction to what actually what does an agent mean? They've been around for a while as a concept, like a really long time, but the reason we're hearing so much about them now is because it's become a lot easier to build them and also have them work well. So the way we're kind of defining an agent with four features. There's a large language model that acts as the brain. So we saw that with every one of those nodes, there was a large language model deciding what to do next. That's the brain. It has access to external tools. Um, it has a memory, so short-term, long-term memory. And it has some sort of reasoning capability to break down problems, plan solutions, plan next steps. It's tricky right now to define what an agent is. There's lots of conflicting opinions as we try to figure it out in the AI space. And I don't think that's a bad thing, right? I think even though the concept's not new, what we can do with agents is new and still developing. And it's going to be really interesting to see what it turns into. And I don't think an agent has to be this autonomous system that's able to access everything and make decisions all by itself and output the perfect response. I think, as an unsolicited opinion, that where we can see the most benefit for agents right now, today, and also looking forward in the nearish future is these purpose-built agents with some amount of human-in-the-loop safety fallback thing. Um, so it's not this autonomous LLM that has access to your bank accounts and social security number and can go in and randomly book flights to Hawaii. Whoops. But it's more this purpose-built agent that's meant to do a specific task and has these guardrails to make sure it stays on track, at least until, they get a little bit better at following the rules. Um, so for example, we saw this in Elysia with a agentic query augmentation. So we saw that when the user inputs a query, it goes into a LLM, and the LLM is going to decide which collection to query or which tool to use based on that user input. So then maybe it'll design a query with different filters, with different aggregation, with a different collection, and be able to reason about this. And then it's going to perform a search and get that context and can decide to do next, or it can just output that response. So this is what we saw. Yeah, so what is the average price per fashion collection is what I did for this one. And we saw that at first it's going to, I really wish I sped this up. It's going to calculate the average price for every fashion collection. It's going to design this query. And this one is actually an aggregate query. So instead of doing the search tree, did the aggregate tree, decides what to group by, and can output a summary. And that's what we saw here. So decide on an aggregate query instead. So super interesting developments in this field. And yeah, this is where I'm really looking forward to seeing what comes next in terms of the horizon. Yeah, good stuff. Okay, I'm gonna take some questions now. I see a lot of them coming in, so let me scroll up. Okay, so I hope I covered what agentic means. Oh no, my mouse is almost dead. That's not good. Okay. Well, hopefully it survives for the next 15 minutes. If not, I'll use my computer over there. But Agentic, so let's go to this blog post that was just by Leonie. And tomorrow's blog post will also go deep into agentic workflows versus agentic architectures and what we mean by that too. So, AI agent is a semi or fully autonomous system that uses an LM of its brain for solving complex tasks. Would definitely recommend checking out this blog post to learn more about an introductory. So, is this real time? We store Slack messages and GitHub issues into the knowledge store in real time. So you could. So this one right now in Elysia is static. We've just AI generated data in here. With if you are into Brandon Sanderson, you'll recognize some of these names. But yeah, so we just AI generated all this data for the purpose of this demo, but you could have it real time where it's real time updating. Um, so depends. Does the AI agent need to have access of the Slack account to get information from the conversations? No. So again, this is AI generated data for the purpose of the demo, but you could use tools like the Slack API or Zapier to basically extract that data and input it into like an Elysia type application. So to be clear, this is sort of our demo application, demoing what might be possible to build with Weaviate and with agents in the coming future, but it's not necessarily meant to be run in production use cases, stuff like that. Okay. Question is for the Verba demo, is the question I ask Verba embedded directly, or is there a pre-query step that has an LLM message that has an LLM augment the query to better fit the data? Yeah, so actually, I'm pretty sure in Verba, this query is just embedded directly. So Elysia does do the query augmentation step, like we saw in here. So it's not taking this and embedding it and searching through it. It's actually doing query augmentation. Verba, I'm pretty sure just embeds the entire query. The reason that this still works pretty well with vector search is that what and is as words don't really convey much meaning. And so the embedding is really just going to be like hybrid search, as its meaning that the vector embedding like represents. And so it's going to be really good at searching that. But again, that's where I think like the agentic query augmentation is going to be really powerful, because if you have a more complex query, a more natural languagey query, the vector embedding straight could struggle. Uh, can we get a link to the Why Verba Sucks talk? Oh gosh, I actually don't think it was recorded. It was at a live event in Berlin back in December, and I don't think we recorded it. So you'll have to come to one of our events sometimes. And it was a fun time. Yeah. Uh, Elysia is, oh gosh, I think it will be released open source eventually. Next week or within the coming weeks, whenever the release is actually pushed out, it will not be released open source at first. And that's because we are not ready to deal with the issues, because it's pretty hard to set up yet, but we will eventually create it so it's super easy to set up like Verba. And then I think we'll release it open source. Um, what are the common pitfalls when implementing Weaviate for RAG applications? Good questions. Let me think. I mean, I think embedding model is super important to think about. Um, Data is super important to think about. Recently, I was trying to build a little RAG app, and I was learning all sorts of things about chunking strategies, and there's just so many little nuances that you can go dive so deep into, um, that really depend on your use case. So I think maybe thinking that it's easy uh, to build something like Verba or like Elysia that works well, it's not that easy. To get something started quickly, yeah, but to have something that actually works well, there's a lot of little things you need to think about, and I think that's where the RAG ebook can also really help. Where is it? Here, yeah, because it goes through like all these little details, what you need to think about, stuff like that. It's free, but yeah. What are sophistications are present in Kappa AI apart from, yeah, so Kappa AI, I not, it's like a product, so I don't think it's open source, but I'm sure they use like specific embedding models and specific strategies for the code, and also these like I'm sure they have a very sophisticated pipeline behind the scenes to be able to answer questions a lot better than Verba can. Like Verba will sometimes like combine all the different languages, like coding languages in one query. So you get something that looks half like Python and half like TypeScript and a little bit of Java thrown in there, which is terrible. But that's why these things are meant to be like demos and not production grade applications. So yeah, I hope that answered the question. Um, Multi-tenancy generally used to increase security and availability. Yes, on both of those. Availability is a great one. Resource costs also. Security for like if you need to isolate different collections. Um, yeah, there's a lot of benefits to multi-tenancy. Um, but we have a lot more information on that. I think we have a blog post that's also really good, but I can't quite remember. What are the best practices for building scalable RAG pipelines? Good question. Vector databases all the way, for sure. Um, I think vector compression techniques can be really good. Um, Also figuring out what models, whether you need to open source, generation models, what sort of data is going in there, and then sort of what queries your user is inputting, right? Whether you need something more advanced or whether you can kind of get away with a vanilla RAG pipeline. Um, so Agentic RAG, does it reason about the retrieved information, not just retrieve the information? Yes. So, for example, in Elysia, it can decide to reason about the output. So if we go to this last tree, basically it did the search, it came up with the response, and then here this LLM node decided to do summary. So then this LLM node took in those results and gave a summary. Um, and so the description up at the top of that little pop out is saying like what this node is for, and then the one under is the reason the LLM gave for doing the thing it did. So the reasoning for the LM that it gave to itself for doing the thing that it did is the user's asking for suggestions. We already queried something, so now we have enough information to provide the user with the summary, so the best action is to provide a summary. So that's actually super fascinating that you can see all of this too within the trees, like what is the LLM actually thinking at each step. Um, yeah, so exactly. Reduces a bit of uncertainty in the user on the output, like what actually went wrong, or like why does it return this really weird response? Maybe you don't know, but now you can have more insight into that. All questions are always good. Okay, yeah, single tenancy in e-commerce projects. So it has to do more about data separation. So you could build an e-commerce application that has multi-tenancy. The problem there is like what do you separate? What data do you separate? Like in a user-based system, you're separating the user-based data so that other users can't access data. But in an e-commerce system, you want all of your users to access the same collection of all of your products, right? So there's no reason to really separate that out. Weaviate has other strategies for dealing with large-scale single-tenant collections to still maintain that high availability and like high speeds. Nodes, sharding, replication, stuff like that. Manage data. No, I don't remember where it is. Concepts? Yeah, okay. Like replication, horizontal scaling. If you're interested in that more, um, we've done some great updates recently on making sure that those single tenant systems can still be available without being broken up into isolated systems. That makes sense. Um, any limits for document size? Any benchmarks available around this? I'm guessing you're talking about Elysia. Not yet. Again, open source demo. So the document size would depend on the model you're using. I'm actually not sure what model they're using for Elysia, to be completely honest with you. Um, and then benchmarks, it's a demo, so you can benchmark on your own data. And we have a great webinar on benchmarking as well. What resources do I use to keep myself updated and tools to create the slides? So slides, I use slides.com. And then I download it as an HTML and host it on my own site. For resources to keep myself updated, that's a little trickier. I am super lucky to have an amazing team that helps keep me updated on all these things. We all have slightly different specialties in what we're interested in. I learned so much from them. And we're also all on LinkedIn, which is super nice. So I think social media, I scroll through LinkedIn a lot, YouTube, things like that. I don't have a specific resource I look at, unfortunately. I also ask people this question. So if you have any good resources, let me know.